So write out each summation and then evaluate if possible. So here we're going to plug in 1 through 6. So that would be 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. So that is going from 1 through 6 and just plugging in each value for k. We could do that by hand, get common denominators, or we could use a calculator. I think on the AP Calc test, this would be under the non-calculator part, but we can do this for pre-calc. We'll just use a calculator, save some time here. We get an answer of 49/20. For the second one, we're going to go from 1 to n. So you see that we don't have a definite starting point. So let's plug in 1 first. We'd have 1 over 1 plus 1, which is 1/2. If I plug in 2, I would have 2/3. If I plug in 3, I would have 3/4. If I plug in 4, I'd have 4/5. So we see the pattern for sure. When I plug in n, I'd have n over n plus 1. So we just put an ellipsis there in the middle to show that the pattern continues, and then at the end we show what the final term would be as n over n plus 1. In other words, I plugged in n for both of the values of k.
EA Sports. It's a game.
So now we're ready for example 7. We want to write the following sum using summation notation. So the first thing we want to do is we want to write the summation sign, if I could. So we can see that we have 9 terms here. So I need my variable, let's say that it's k, to go from 1 to 9. And we can see that each term inside there is just 1, 2, 3, 4, 5, 6, 7, 8, 9. So my base is just going to be k, and I'm always raised to the second power. So that would be how we could rewrite that summation using summation notation. Okay, so this is where we started getting into the actual tough stuff. So we can see here that if I have a constant times my different terms, I can simply move my constant out in front of the summation. So in other words, if every term is being multiplied by 3, I could move the 3 out in front, find the summation, and take that answer times by 3. Also, if I have addition happening inside of the summation, it's equal to the addition of each separate summation. Same thing is true with subtraction. If the index does not start at 1, so in other words, if I'm going from like 17 to 34, so we can see here I'm going from 17 to 34, so that would be 16 plus 1. I'd want to go from 1 to n and from 1 to j, and then subtract those two answers out. So in other words, I'd find if this was going from 17 to 34, I would go from 1 to 34 and 1 to 16, and then subtract those two separate summations. These are shortcut formulas. So of course, if I'm just adding a constant together, it would just be equal to how many numbers I have. Another way of saying this is if I had k going from 1 to n of 5, that would just be 5n. So it just happened to be equal to 1n because we're adding 1s up every time. If I'm adding 1, 2, 3, 4, 5, 6, 7, 8 onto n, this is the formula, n times n plus 1 over 2. That is something that you will use in AP Calc quite a bit. That's one of those formulas that you just have to memorize. If we're adding up all the squares, such as what we were doing on the previous screen, this is the formula that we have found for that, and then the one for cubes is here. So you might want to keep these charts handy just to come back to to look at as you need it for different problems. Okay, so we can see here on example 8 that we are simply using a constant. In other words, there's no variable in it. So I'm just going to take 1/2 times 100, because I'm going to have 100 of these 1/2s added together. So that answer would be 50, and we're done with the problem. You can think of this as you're taking 1/2 plus 1/2 plus 1/2 100 times. So that's why that shortcut formula works. For example 9, first thing I see here is that we have a 3 multiplying it. So I'm going to change this to 3 times the summation k equals 1 to 5 of k. For this part here, we're going to use the shortcut formula of n times n plus 1 all over 2. And then we're going to take that answer times by 3 because of that 3 out in front. So I'm going to take 3 times, my n is 5, so 5 times 5 plus 1 over 2. So I need to take 3 times 5 times 6 divided by 2, which is 9 times 5 is 45. Okay, so now we're ready for our last example here. What we're going to use for this one is from a reference sheet. Whoops.
Is it recorded?
Yes. From a reference sheet, we're going to use the k equals 1 to n of k squared. And that shortcut formula is n times n plus 1 times n plus 2 all over 6. Now what we can see here is that my k is really k plus 2. So that's what I'm going to be putting in for my values of n. So I'm going to have k plus 2 times k plus 2 plus 1, which is k plus 3, and k plus 2 plus 2, which is k plus 4, all over 6. Now my k value is 8, so I'm going to plug in 8 for that. So I'm going to end up with 10 times 11 times 12 divided by 6, which is 10 times 11, which is 110. 12 divided by 6 is 2, so take 110 times 2 is 220. And that's our final answer. Now you should grab your homework and work on it.